Alright, welcome everyone back to the stream. Today is day 7 already. We've been going at it for a week and we've made some pretty good progress. Honestly, yesterday after I stopped the stream I continued working for a little bit more after I took a short break, and we have that task fully done yet with all the bonus points, everything. This is the Etch-a-Sketch project. And we can change the size of the grid, so on. As you can see, it inputs random colors, and each time you go over a certain tile, the color gets more opaque. And those were the bonus points for this task. I've already submitted it. I'll see if I can open up my VS Code. Yeah, just a second. I'll quickly show you the code and show you what I did. So code. Right, let me put it on the side. So basically this is the HTML, nothing too fancy. The CSS here with all the styles in order for us to have a grid using Flexbox. And this now is the JavaScript. I had to set a flag here, is mouse down, in order to do the bonus points. We ask size, but by default the grid is 16 by 16. That was one of the requirements. And then if we ask for a size, it goes in a nested loop and creates the grid. We also need to clear the grid once we ask for size. We have a function paint that will paint each tile on mouse down and on mouse enter, and when we let go of the mouse via mouse up, it will turn this flag off. This is the function to get a random color, and this is the one to increase the opacity. And I've already committed this to Git. Let me just open up the stream to see if I have any messages already. Just a second. Yeah. I've received a lot of comments and subscribers overnight, which again I'm really truly thankful of. Appreciate you guys supporting me in this journey, and hopefully I inspire you in this journey, and hopefully to code like me every day and pursue your dreams. So yeah, right now, after I've submitted the project, we're almost done with the foundations course. We're 93% done, and the only thing we have to go through are the object basics and the calculator project, which I'm very pumped about. I think it's going to be really cool to make a calculator. Now we're going to go through the objects together. We're going to go through the objects together today. Do you have a background in dev before that challenge? Yes. I haven't gone into university, or I haven't studied traditionally, but I went to a bootcamp where I learned Java and Spring. So I have some full stack apps that are buried inside GitLab. I'll probably not be able to wait. GitLab. Yeah, I'm not sure if I'll be able to find my GitLab account. I used it during the bootcamp to create a couple of full stack applications. After that, I didn't find a job with Java, but I found a job with COBOL, mainframe COBOL. I'm not going to log in for now, I'm too lazy. Let me just see if I'm going to be able to find it like that. Yeah, so there is my GitLab repository. And can I see my activity? It was 2 years ago, as you can see. And I had a colleague there from the bootcamp that we were doing the project together. But yeah, after that I found a job with mainframe COBOL, which is, if you don't know about COBOL, it kind of looks like that. Like this is COBOL, but nonetheless pretty boring. It's pretty simple, pretty boring, and I want to pursue full stack now. So I know a little bit of JavaScript before that and HTML and CSS, but I have forgotten most of it, so I'm going through the Odin project now on stream. That's an old language, if I remember. Yes, really old language that is only good for certain things, like banks use it to process transactions and so on, and their whole infrastructure is built on COBOL, and if they want to change it, they cannot really, or it will take them a long time, or they'll have to wait until AI can do it in a second. But yeah, this is why it still exists, because there is a lot of code written that has to be maintained. But yeah, that's kind of my background. If you look at GitHub, I first started coding, let me open up my profile. I first started coding in 2018 when I was 17, but as you can see, I haven't been consistent at all, at least in committing to GitHub. And actually, I believe this is the most consistent I've ever been. As you can see, from 2018, if I started 2018 and kept at it when I was 17, bro, I would have made it by now. But yeah, shit happens, so we're starting over. And yeah, I showed you the Etch sketch, I've already submitted it, and today we're going to go through the object basics. In Java, I remember that everything is an object, but in JavaScript I'm not sure, so we'll go through it together. Okay. And I know there are some pretty cool functions you can use on objects. Alright, let's see now. Congratulations for making it to one of the last lessons in Foundations. By this point you have learned many of the fundamentals of JavaScript. In this lesson you will learn about objects, a collection of key value pairs, as well as some more powerful and commonly used array methods. Before you know it, you have a better understanding of how powerful objects and arrays are, and how both can be indispensable part of your JavaScript toolkit. So we're going to learn about creating objects, accessing object properties, using multiple object operators, understanding the differences between object and primitive data types, using map, filter and reduce array methods. Alright, let me just see how long this lesson is going to be. If we have a lot of we don't have a lot of additional resources. Alright, I think we'll go through it today, and we can get started with the calculator project. So objects are a very important part of the JavaScript language, and while for the most part you can accomplish simple and even intermediate tasks without worrying about them, any real project that you're going to attempt is going to feature objects. The uses of objects in JavaScript can get deep relatively quickly, so for the moment we're only going to cover the basics. There will be an in-depth dive later. Alright, so just the basics. This javascript.info article on objects is the best place to get started. Alright, so we'll look through that, and the MDN tutorial on objects isn't bad either, so check it out if you need another take on the subject. What I do is when I go through these tutorials, I try to get through all the links they provide, and yeah, just get at least the fundamental knowledge as good as possible. So we'll start with this, and what I like to do is kind of not to get what was it? I delete everything I have like in the background or on the side, so I don't get distracted. Alright, so kind of like that. Alright, so objects, as we know from the chapter data types, there are 8 types in JavaScript. 7 of them are called primitive because their values contain only a single thing, be it a string or a number or whatever. In contrast, objects are used to store keyed collections of various data and more complex entities. In JavaScript, objects penetrate almost every aspect of the language, so we must understand them first before going in depth anywhere else. An object can be created with the figure brackets or curly brackets, which is an optional list of properties. A property list is a key value pair where key is a string, also called property name, and value can be anything. We can imagine an object as a cabinet with singled files, with signed files. Every piece of data is stored in its file by the key. It's easy to find the file by its name and how to remove a file. Right, so an empty object or an empty cabinet can be created using one of two syntaxes. So either with new object or with just with the object literal. The new object is called an object constructor. Usually the figure brackets are used. That declaration is called an object literal. Literals and properties, we can immediately put some properties into the brackets as key value pairs. So if you have an user, you can store its name as John and age as 30. Okay. A property has a key, also known as name or identifier, before the colon, and a value to the right of it. In the user object there are two properties, so the name, as I said, and the age of 30. The resulting user object can be imagined as a cabinet with two signed files labeled name and age. So this is a pretty good depiction of objects. I kind of like this. Alright. So we can add, remove and read files from it at any time. Property values are accessible using the dot notation. So if you alert user.name, you get John, and if you alert user.age, you get 30. The value can be of any type. Let's add a boolean one. So user is admin is true. To remove a property, we can use delete operator, delete user.age. This is strange how it's not like user.age.delete, but delete user.age. This is interesting. We can also use multi-word property names, but then they must be quoted. So multi-word property names, if you want a space in between them, likes birds, true. Alright, likes birds. I see. The property in the list may end with a comma. That is called a trailing or hanging comma. Makes it easier to add, remove, move around properties because all lines become alike. Square brackets for multi-word properties, the dot access doesn't work. Right, so you have to put them in the brackets. JavaScript doesn't understand that. It thinks that we try to access user.likes and then gives a syntax error when it comes across unexpected birds. The dot requires the key to be a valid variable identifier. That implies contains no spaces, doesn't start with a digit, and doesn't include special characters like $sign. So $sign and underscore are allowed actually. There is an alternative square bracket notation that works with any string, so you just put the string in quotes and then in those brackets. That's how you set user likes birds to true. You can after that get it by alerting user likes birds. It will give you a result of true, and then you can delete this key value pair. So now everything is fine. Please note that the string inside the brackets is property quoted. Any type of quotes will do. So you can use single quotes, double quotes, back quotes. Square brackets also provides a way to obtain the property name as the result of any expression, as opposed to a literal string like form of variables follows. Square brackets also provide a way to obtain the property name as the result of any expression, as opposed to a literal string like form of variables follows. So same as right. So in this second example, your equals true, same as likes birds true. Like this one I kind of don't get it. Can I get a JavaScript sound? I think it's important whenever you don't get something to test it and see how it works. It's already run. Alright. So let key equals likes birds. First probably you have to make the object. User key equals true, same as user likes birds equals true. Please note that the string inside the brackets is property quoted. Square brackets also provide a way to obtain the property name as the result of any expression. So let's do this. Above it, so it will alert true, and then after that can we console, like every time I write something it automatically saves and it runs it, and I cannot write because there is this alert, so I'm going to comment it for now. Console.walk key and also user key. Right, so I get why user key is true, but why is it the same as user likes birds? Wait. Console log user, and we can make so they're both true. What happens if I console log user likes birds to see if it equal to user key? So this is also true. User key equal true. User likes birds is true. Right. So this object kind of looks like this. Wait, can we console log the object? Console log user. I've put a comma instead of the dot, so like likes birds is true. User key equals true. But when we look at the user, he only has the likes birds is true, but the key we set here is not visible. Please note that the string inside the brackets is properly quoted. Any type of quotes will do. Square brackets also provide a way to obtain the property name as the result of the expression. So, square brackets also provide a way to obtain the property name as the result of the expression. I still don't quite get it, but let's read this. Here the variable key may be calculated at runtime or depend on the user input. And when we use it to access the property, this gives us a great deal of flexibility. So for instance, user John age 30, alright. Let key prompt. What do you want to know about the user? John. And let's say his pet's name, let's say. We add into the prompt. So the key here will be his pet's name, and access by variable alert user key. So John's pet's name. What do you want to know about the user? I think this question is not asked correctly, because here you set a key value pair for the user, but they're asking you what do you want to know. So this implies you don't know and you're asking something for the user. If you say like what is his pet's name, then alert user key will be like what is John's pet's name, but they really mean you can set it here. So you can say user.key will be Jake, for example, if it's his pet name. Anyways, the dot notation can be used in a similar name. So let me actually try to run this once. User has already been declared, of course. There you go. What do you know? What do you want to know about his pet's name? Undefined. Wait, I might be wrong here. So if we say age, you get his age. Now I understand, right? I was a dummy there. So you can refresh it. No, wait. I want to know his name. So this is a way of accessing keys like a reserved keyword. So I kind of get it now. If you set this key to likes birds, it will access user likes birds. Right, now I get it. Is key reserved word in JavaScript reserved words I don't think key is a reserved word. Like for example, you can say let dog sorry, can I write it in one try? I overwritten it. Okay, so user dog, if you say age 30. Alright, so they use key just so you can better understand it, but actually this can be any word and it will refer to the property name. So I understand it now. Alright, see if I didn't test it here, what will alert user key give me? I wouldn't have understood it. So it's very important to test what you're learning about to better understand it. Alright. The dot notation cannot be used in a similar way. It will give you undefined because there is no user key right now. If it was user.h, it will give you 30, but user.key is not in the object, so you cannot access it like that. So computed properties. We can use square brackets in an object literal when creating an object. That's called computed properties. For instance, you have a bag object and you make square brackets fruit 5, which fruit do you want to buy. So first it will ask you for a prompt and to store your whatever you've written in the keyword fruit. So if you say apple, then the object will contain the object will be bag of 5 apples. So the name of the property is taken from the variable fruit, right? So, and then after that you can access it with bag.apple. The meaning of a computed property is simple. Fruit in brackets means that the property name should be taken from fruit. So if a visitor enters apple, bag will become apple 5. Essentially that works the same as, so you get a fruit, so it's defining it outside the object itself. Take property name from the fruit variable, apple, let's see, dog. Yeah, we cannot see the outcome, but I guess that's how it works. But looks nicer. Essentially it's the same as, but looks nicer. We can use more complex expressions inside square brackets. So you can say Apple computers 5. Alright. Square brackets are so much more powerful than dot notation. They allow any property names and variables, but they're also more cumbersome to write. So most of the time when property names are known and simple, the dot notation is used, and if we need something more complex, then we switch to square brackets. Property value shorthand. In real code, we often use existing variable names for property names. For instance, function make user returns name with the given name and age with the given age. It's like a constructor, and we use let user and we call the function. So the let user will now return an object of name John and age 30. This is like a constructor way of doing it with the function. In the example above, properties have the same names as variables. The use case of making a property from a variable is so common that there is a special property value shorthand to make it shorter. Instead of name, we can just use name like this. I wonder if this is just for name and age. So in the above example, properties have the same name as variables. So for example, if you want to use the same, is that JavaScript? Yes, it is JavaScript. Thank you for tuning in and leaving a comment, man. Really appreciate it. It is JavaScript. Learning about objects today. So I'm getting, let me just copy that real quick and we'll edit it. So, and let me comment the alert for now. So if we want instead to use dog and dog, we can then access user dot dog like that, and it will give us 30. But if it's the same name here and here, we can shorthand it and just use dog. Is that the case? Yeah. And it still gives us 30. So it's the same name on the left and on the right, you can shorthand it no matter what it is. That's really cool. I like it. In the above example, both properties have the same names as variables. The use case of making a property from a variable is so common that there is a special property value shorthand to make it shorter. Yeah. So what I just made here, right? We can use both normal properties and shorthands in the same object. Really cool. So property name limitations. As we already know, a value cannot have a name equal to one of the language reserved words like for, let, return, etc. But for an object property there is no such restriction. Alright, so it's very interesting. In an object you can use the reserved keywords. In short, there are no limitations on property names. They can be any strings or symbols, a special type of identifiers to be covered later. In other types are automatically converted to strings. So I'm wondering if you can use like a special symbol, let's say a hashtag here and here, and use user.hashtag. Yeah, I'm not sure that works. Can we do it like that? Nope. And you can use return, for example. Return. But maybe you have to give it a value. No. Alright, so this is not working as expected. Let me see if this will work. Yeah, it gives me 6. What if we say here hashtag and object.hashtag? So there are limitations indeed, as I can see. You can use the reserved keywords but not some special characters. And it says there are no limitations on property names, but yeah, I don't know, maybe I'm doing something wrong, but I don't think that's the case. Let me just check something real quick. Alright. For instance, a number 0 becomes a string 0 when used as a property key. Alright. There is a minor gotcha with a special property named proto. We can't set it to a non-object value. Alright, I think it's because of this. If we comment that out and we say console.walk obj in brackets, we get the object and the prototype, and this is the proto underscore. We'll cover the special nature of proto in subsequent chapters and suggest the ways to fix such a behavior. Alright. Property existence test in operator. A notable feature of objects in JavaScript compared to many other languages is that it's possible to access any property. There will be no error if the property doesn't exist. Reading a non-existing property just returns undefined, so we can easily test whether the property exists. So we create an empty user object and we try to access no such property, which equals undefined, and it will return true in the alert because user.noSuchProperty is indeed undefined because it doesn't exist. So there's also a special operator in for that. The syntax is key in object, and for instance, if we let a user again with the name of John and age 30 and we try to alert age in user, it will return true because age exists in user, and blah 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 will return false because it doesn't exist in the user object. Alright, so please note that on the left side of in there must be a property name. That's usually a quoted string. If we omit quotes, that means a variable should contain the actual name to be tested. So for instance, alright, so if we alert key in quotes, it will alert false, but if we use key as a variable, it will alert true because key is equal to age and age exists in that object. Why does the in operator exist? Isn't it enough to compare against undefined? Well, most of the time the comparison with undefined works fine, but there is a special case when it fails but in works correctly. It's when an object property exists but stores undefined. Right. So I guess it's better to use the in keyword in that case. So if anything is undefined, let's see, they make an object again with the property of test and value undefined. They try to alert object.test, which is undefined. It will return undefined, and if they alert test in object, it will return true. So in the first case, you may think that there is no such property, but actually there is. It's just the value is undefined. In the code above, the property object.test technically exists, so the in operator works, right? Situations like this happen very rarely because undefined should not be explicitly assigned. We mostly use no for unknown or empty values, so the in operator is an exotic guest in the code. The for in loop. To walk over all keys of an object, there exists a special form of the loop for in. This is a completely different thing from the for loop construct that we studied before. The syntax is for key in object executes the body for each key among object properties. For instance, let's output all properties of user. So we have an object user with name John, age 30, and is admin true, and we do for let key in user. So for every key in user, alert key, which is name, age, and is admin. And if we do alert user key, it is John, 30, and true. Alright, perfect. Note that all four constructs allow us to declare the looping variable inside the loop, like let key here. Also, we could use another variable name here instead of key, for example, let prop in object, which is also widely used. Ordered like an object. Are objects ordered? In other words, if we loop over an object, do we get all properties in the same order they were added? Can we rely on this? The short answer is ordered in a special fashion. Integer properties are sorted, others appear in creation order. The details follow. So, as an example, let's consider an object with the phone codes 49 Germany, 41 Switzerland, 44 Great Britain, 1 is USA, and so on. So we loop through them, and for each code in codes, alert the code, and it will alert the keys in the following order, which is sorted. This is an interesting. This is interesting for me because this is like a way to sort an object or an array. The object may be used to suggest a list of options to the user. If we're making a site mainly for a German audience, then we probably want 49 to be the first, but if we run the code, we see a totally different picture. USA goes first, then Switzerland, which is 41, and so on. The phone codes go in the ascending sorted order because they are integers. So we see 1, 41, 44, 49. Integer properties, what is that? The integer property term here means that a string can be converted to and from an integer without a change. So 49 is an integer property name because it's transformed to an integer number and back. It's still the same, so but plus 49 and 1.2 are not. Alright, so if we use plus 49, plus 41, plus 44, it will output them in the order that we've written it, if I'm correct. Let me try this out because I'm curious. We're just not going to use alert but console log because this is annoying here. So we use console.log and we get the codes. Now if we write a plus in the beginning, that's right, they are written in the order that were their output in the order that they've been written. Right, so where are we? So to fix the issue with the phone codes, we can cheat by making the codes non-integer, adding a plus sign before each code is enough. Alright, now it works as intended. I'm curious if there are not phone codes, if there is a way to fix it. Probably there is, but I don't think they mention it here. Alright, summary objects are associative arrays with several special features. They store properties as key value pairs, where property keys must be strings or symbols, but usually strings, and values can be of any type. To to access a property, we can use the dot notation of object dot and then the property name, square brackets notation object property, square brackets allow taking the key from a variable like object var with key, square brackets allow taking the key from a variable. Additional operators are the delete, in operator, and the for in loop. What we've studied in this chapter is called a plain object or just object. There are many other kinds of objects in JavaScript. So array to store ordered data collections, date to store information about the date and time, error to store information about an error, and so on. So the array is also an object. They have their special features that we'll study later. Sometimes people say something like array type or data type, but formally they are not types of their own but belong to the single object data type, and they extend in various ways. Objects in JavaScript are very powerful. Here we've just scratched the surface of a topic that's really huge. We'll be closely working with objects and learning more about them in future parts of the tutorial. Alright, so we have a couple of tasks here. Let's see if write the code, one line for each action, and if we click here, what happens? Alright, we can maybe put it on the right and this one on the left. So I'm going to remove all that, create an empty object of user. So let user, and we can create it like that. Add the property name with the value John. So user I think we can add it like that. User name equals John. Add the property surname with the value Smith. It will be the same, so we can just copy it. Surname Smith. Change the value of the name to Pete, so user dot name equals Pete. Remove the property name from the object, so delete user dot name. And let's see the solution. So they define the user the same way. Now I've used the bracket notation, which I'm not sure it will work. So let me just console.walk user. Yes, it will work the same way. I guess there are just different ways of doing it. User.name Pete, and it's basically the same. Alright, so this is done. Check for emptiness. Write a function is empty object, which returns true if the object has no properties and false otherwise. Should work like that. So let's schedule is empty, and if we alert is empty with the object of schedule, it returns true, but if we add some values it will return false. So I guess we can use the in or the for in actually. Let's do function is empty, and we'll take in the object and we write inside for let key in object can we just do a return true, and if there isn't, we can do return false, because if there is any key in object, then we'll return true, and if not, we'll return false. But I don't know, let's try it. So console.log user, not user but is empty, and use the object of user. It will give us true. Now this shouldn't be the case. Let me just see if it matters where we put it. No, it doesn't matter. And if we do a new object, let's say user2, it will give us false. Alright, this is strange. Can we false and here give true? So this way user2 is actually empty and it gives us true, and user1 is false because it's not empty. But I'm not sure why that works, because here we're doing a loop for key in object. So for every key in object, return false, and if not, return true. I don't know why it works like that. They've written it exactly the same way. If the loop has started, there is a property. So why should we return false if there is a property? Just loop over the object and return false immediately if there is at least one property. Is empty. Right, I got it. I understand it. So if there are properties, is empty will be false, and if there isn't a property, is empty will be true. Alright, so I've written it exactly the same way, but I just didn't understand it. Okay, next one, some object properties. We have an object storing salaries of our team. Write the code sum all salaries and store them in the variable sum. Should be 390 in the example above. If salaries is empty, then the result must be 0. Alright, so can we copy that? Yes, we can. Perfect. And also let sum equals 0. So for salary in salaries, so for it should be person actually, because this is referring to the property key. So for person in the salaries array, and we actually have to let person in salaries sum plus equals person dot can you do it like that? Console.log sum? No, you don't. Value of person cannot convert undefined or no to object. So how do we access the value of each key? Not a number. Let me see it. Sum pos equals salaries. So we do salaries and in brackets person. Alright. And we have one last one. Multiply numeric property values by 2. Create a function multiply numeric that takes an object that multiplies all numeric property values of object by 2. So width and height will multiply it and title will not. Please note that multiply numeric does not need to return anything. It should modify the object in place. Use the type of to check for a number here. Alright, so we need this and the function to multiply numeric. We'll do function that will take menu, let's say. So for let key in menu, this probably has to be in brackets. So for every key in menu, if key dot type of sorry to interrupt, but unfortunately have exceeded the limit of 8 lines of code. Please delete some of the alright, okay. How to use type of, how to use so type of, and it has to equal number if, no, I cannot write it. So what I was going to write is if type of key double equals number, then do menu and key in brackets equals menu key in brackets times 2. So they do multiply numeric, they take in an object, and they do for key in object until here is the same. If type of, right, it's a number, times equals to, yeah, basically the same. I was going to write object key equals object key times 2, but times equals is the same and it's shorter. Alright, so we're done with that. Can I merge those two together? Alright, whatever. I'll leave it side by side again. So this is done with the objects. I'm going to close this one for now. Alright, yeah. Okay, so we went over this and now we have to go over the MDN tutorial. Which is quite lengthy again. Let me get rid of the things on the side. So this I don't need, this I don't need, this I don't need. Okay. So we'll go through that, but before that I want to take a quick break, so I'll be gone for 15 minutes, just taking a break and resting for a little bit, and I'll be back so we can go over this MDN article on objects, and hopefully we can get through this today and start on the calculator app. Alright, so it's been about an hour, so I'm taking a break, 15-minute break, and I'll be right back, guys. Alright, I am back, boys. Thank you so much for sticking with me. Let me show you something. Something just came in the mail. Alright, so this is a concept for my new logo. It's still not done, but the guy just sent it to me. This is the other one, but I don't like it as much. This is the other one, but I think I like this a bit more. It's mirrored, by the way, so it's VC, but it's mirrored. But I'm probably going to suggest some changes. We'll see. I like it more than my current one, though. The current one I made myself. Alright. So we're done with that, and we're on to JavaScript Object Basics by MDN. I forgot to make myself a coffee. Anyways. Alright, so in this article we look at fundamental JavaScript object syntax and revisit some JavaScript features that we've already seen earlier in this course, reiterating the fact that many of the features you've already dealt with are objects. Prerequisites: a basic understanding of HTML and CSS, familiarity with JavaScript basics, so on and so forth. Object basics. An object is a collection of related data and or functionality. These usually consist of several variables and functions, which are called properties and methods when they are inside objects. Let's work through an example to understand what they look like. To begin with, make a local copy of all.js.html. So I don't think I'll be going through that. I think I'll be able to understand it as we already went through the previous article. This contains very little script element for us to write our source code into. We'll use this as a basis for exploring basic object syntax. While working with this example, you should have your own developer tools, JavaScript console open and ready to type in some commands. As with many things in JavaScript, creating an object often begins with defining and initializing a variable. Try entering the following line below the JavaScript console that's already in your file, then saving and refreshing, and they basically just make a constant variable named person, which is an object or an object literal. Now open your browser's JavaScript console and enter person into it and press enter. You should get the result similar to one of the lines below. Congratulations, you just created your first object. Job done, but this is an empty object, so we can't really do much with it. Let's update the JavaScript object in our file to look like this. So name is an array of names, age is 32, and for bio they have a function which will console log Bob 32 is, I don't know, Bob Smith is 31 years old, is 32 years old. Hi, I am this name 0. Introduce yourself. I'm wondering why they have two names in the beginning. Like, I understood this is an array. Anyways, after saving and refreshing, try some of the following into the JavaScript console on your browser DevTools. Bob Smith is 32 years old. Hi, I am Bob. Alright. You have now got some data and functionality inside your object and are now able to access them with some nice simple syntax. So what is going on here? Well, an object is made up of multiple members, each of which has a name and a value. Each name value pair must be separated by a comma, and the name and value in each case are separated by a colon. The syntax allows the following pattern. Alright. The value of an object member can be pretty much anything. In our person object we have got a number, an array, and two functions. The first two items are data items and are referred to as the object's properties. The last two items are functions that allow the object to do something with that data and are referred to as the object's methods. When the object's members are functions, there is a simpler syntax. Instead of bio function, we can just write bio like this. So yeah, instead of a key and then a nameless function, we can just use a function as the key name. Okay, from now on we'll use this shorter syntax. An object like this is referred to as object literal. We've literally written out the object contents as we've come to create it. This is different compared to objects initialized from classes, which we'll look at later on. It is very common to create an object using an object literal when you want to transfer a series of structured related data items in some manner. For example, sending a request to the server to be put into a database. Sending a single object is much more efficient than sending several items individually, and it's easier to work with than an array when you want to identify individual items by name. Dot notation. Above you access the object's properties and methods using dot notation. The object name person acts as a namespace. It must be entered first to access anything inside the object. Next you write a dot, then the item you want to access. This can be the name of a simple property, an item of an array property, or a call to one of the object's methods, for example person.h or person.bio, the bio function. Objects as object properties, so you can put an object inside of an object. An object property can itself be an object. For example, try changing name member from Bob and Smith to name first and last name in an object. To access these items, you just need to chain the extra step onto the end with another dot. Try this in the JS console. So person.name.firstName, it will return Bob, and person.name.last will return Smith. Alright, so if you do this, you also need to go through your method code and change any instances of name0 and name1 to name.first and name.last. Otherwise your methods will no longer work. The bracket notation, went too far. Bracket notation provides an alternative way to access object properties. Instead of using dot notation like this, person.h or person.name.first, you can instead use square brackets of person h or person name first. This looks very similar to how you access the items in an array, and it's basically the same thing, Instead of using an index number to select an item, you're using the name associated with each member's value. It is no wonder that objects are sometimes called associative arrays. They map strings to values in the same way that arrays map numbers to values. Alright, this makes a lot of sense. Dot notation is generally preferred over bracket notation because it is more, I'm not going to try to pronounce this word, it will not work out, and easier to read. However, there are some classes where you have to use square brackets. For example, if an object property name is held in a variable, then you can't use dot notation to access the value, but you can access the value using bracket notation. In the example below, the walk property function can use walk person property name to retrieve the value of the property named int property name. So let's check that out. We've got a const person again of Bob Smith age 32, and the function walk property takes an input of property name and console walks person property name. So walk property of name will output person and in square brackets name, which will output this, and same for each. Walk property age will console walk property age, which will return 32, which is pretty straightforward. Alright, setting object members. So far we've only looked at retrieving or getting object members. You can also set or update the value of an object members by declaring the member you want to set using dot or bracket notation like this. So person.age 45 will set the age of the person object to 45, and person name last equal to Cratchit. Try entering the above lines and then getting the members again to see how they've changed, like so. Person.age and then person name last. Setting so yeah, this will return 45 and this will return Cratchit. Setting members doesn't just stop you. Setting members doesn't just stop at updating the values of existing properties and methods. You can also create completely new members. Try this in the JS console. So person eyes equal Hazel, and person farewell function will console walk by everybody. So if you don't try to retrieve anything, if you don't just try a console walk person eyes, this will return undefined, and if you do person farewell, I guess it will as well return undefined. But if you use the equal sign, you can assign something and make a new what was it called, the thing on the left, key value pair, a new key, and you assign a value to it as well, and after that you can use it. One useful aspect of bracket notation is that it can be used to set not only member values dynamically, but member names too. Let's say we wanted users to be able to store custom value types in their people data by typing the member name and value into two text inputs. We could get those values like this. So const my data name equals name input dot value, and my data value equals name value dot value. We could then add this new member name and value to the person object like this. Person my data name equals data value. I see. Alright, to test this, try adding the following lines into your code just below the closing curly brace of the person object. So in other words, after you define the person object, you can set to constant variables my data name, for example height, and my data value to be 175, and then after that you can set person height equals to 175. Now try saving and refreshing and entering the following into your text output: person height, which will give you 175. Adding a property to an object using the method above isn't possible with dot notation, which can only accept a literal member name, not a variable value pointing to a name. What is this? So yeah, I could never before understand this keyword fully. So this time let's try to understand it. You may have noticed something slightly strange with our methods. Look at this one, for example. Console walk. Yeah, this was in the beginning. So introduce self console walk. Hi, I am this dot name 0. You're probably wondering what this is. The this keyword typically refers to the current object the code is being executed in. In the context of an object method, this refers to the object that the method was called on. Alright, let's illustrate what we mean with a simplified pair of person objects. So person 1 name is Chris, and introduce self is hi, I am person 1 dot name. So this dot name equals person dot name, and person 2 is the same one, but it will be introduce self will mean person 2 dot name, or this dot name. In this case, person 1 introduce self outputs hi, I'm Chris, and person 2 introduce self outputs hi, I'm Deepti. This happens because when the method is called, this refers to the object on which the method is called, which allows the same method definition to work for multiple objects. This isn't hugely useful when you are writing out object literals by hand, as using the object name person 1 and person 2 leads to the exact same result, but it will be essential when we start using constructors to create more than one object from a single object definition. That is the subject of the next section. So introducing constructors. Using object literals is fine when you only need to create one object, but if you have to create more than one, this, as in the previous section, they're seriously inadequate. We have to write out the same code for every object we create, and if we want to change some property of the object, like adding a height property, then we have to remember to update every object. We would like a way to define the shape of an object, the set of methods, and the properties it can have, and then create as many objects as we like, just updating the values for the properties that are different. The first version of this is just a function, so we can have a function create person with the name of the person, and this function will create a new object with object.name equals name, and object.introduce self will console log hi, I am object.name, and you return the object. This is also what we had in the previous lesson. So this function creates and returns a new object each time we call it. The object will have two members, a property name, a method introduce self. Note that create person takes a parameter name to set the value of the name property, but the value of introduce self method will be the same for all objects creating this function. This is a very common pattern for creating objects. Now we can create as many objects as we like, reusing the definition. So you can have Salva, create person Salva, and when you introduce self, it will say hi, I'm Salva. You can do the same with Frankie, and when you execute introduce self on Frankie, it will say hi, I'm Frankie. I think that was polymorphism. Don't quote me on that though. This works fine, but it's a bit long-winded. We have to create an empty object, initialize it, and return it. A better way is to use a constructor. A constructor is just a function called using the new keyword. You can, when you call a constructor, it will create a new object. Bind this to the new object so you can refer to this in your constructor code. Run the code in the constructor, return the new object. So constructors by convention start with a capital letter and are named for the type of object they create. So you could rewrite our example like this. Function creates a person with the name, this.name, and this.introduce self equals the function of console logging, hi, I am this.name. And as I can see, this is shorter because there is no need to create the object and to return the object. It's this.name and this introduce self. Function person, create person. It's written with a capital letter. So I can see the only difference when creating this function is you remove the create from here and it just starts with person name. I'm just curious how it understands that this is a constructor and to make the object and return it. To call person as a constructor, we use new. So if we don't use the new keyword when we're creating the new people, it will just think that this is a regular function and not a constructor. I'm just curious how this is going to work if we don't use new. But anyways, you've been using objects all along. As you've been going through these examples, you have probably been thinking that the dot notation you've been using is very familiar. That is because you've been using it throughout the course. Every time we've been working through an example that uses a built-in browser API or JavaScript object, we've been using objects because such features are built using exactly the same kind of object structures that we've been looking at here, albeit more complex ones than in our own basic custom examples. So when you used when you used string methods like myString.split, you are using a method available on a string object. So strings are also object. I think everything is an object actually. I learned this from Java, but I don't know if it's the same in JavaScript. Every time you create a string in your code, that string is automatically created as an instance of the string object and therefore has several common methods and properties available to it. Okay. So when you accessed the document object model using lines like this, document.createElement and document query selector, you are using methods available on the document object for each web page loaded. An instance of document is created called document. That makes a lot of sense, which represents the entire page structure, content, and other features such as its URL. Again, this means that it has several common methods and properties available to it. The same is true of pretty much any other built-in object or API you've been using, array, math, and so on. Note that built-in object APIs don't always create object instances automatically. As an example, the notification API, which allows modern browsers to fire system notifications, require you to initialize a new object instance using the constructor for each notification you want to fire. Try entering the following into your JavaScript console. I don't know if anything will happen if we just enter that without calling it. Cons my notification, my notific. Yeah. Alright, anyways, test your skills. You've reached the end of this article, but can you remember the most important information? You can find some further tests to verify that you've retained these information before you move on. Alright. Summary, so on. Alright, we've done with this, and let's check out now differences between objects and primitives. So wait, let me zoom that in. Earlier in the curriculum, you've learned about primitive data types. Now that you've seen the object data type, which includes but is not limited to objects as key value, arrays, and functions, the main difference between the two is that primitives can contain only a single thing, such as number, string, etc. Objects data types are used to store a collection of data and more complex entities. Besides the formal differences, there are also some technical differences which affect how we use each data type. When you define a primitive variable, it will contain a copy of the information provided to it. When you define a primitive variable, it will contain a copy of the information provided to it. So it will, what you write in here, if you pass it to data copy will store it once, but once you update data copy, the original one will stay as is, and I believe if you update data copy will also actually I'm not sure about that. Let me just let me try to see if that's the case. What if we instead do data and make it this is annoying, exceeded 8 lines of code. Like, what can I possibly write in 8 lines of code? I'm not here. anyways. Sign in to fork. Alright, I guess we'll never know anyways. On the other hand, when you define an object variable, it will contain a reference to the object provided to it. So object contains a reference to the object we defined on the right side. Object will contain a reference to the object referred by obj. Making changes to object copy will make changes to the object that it refers to. So object obj will also be 43 if we change it. That makes sense. This behavior isn't new to you. In your last project you made changes to the cells in the Etch-a-Sketch grid by using references. Let's take this code snippet as an example. So const element from document query selector container element.style background equals red. We're mutating the variable we declared element, yet the changes affect the corresponding node in the DOM. We're mutating the variable we declared element, yet the changes affect the corresponding node in the DOM. Why does this happen? I never thought of this, but that's true. It's like kind of what we're doing here. I've always thought of this as like a shortcut. Instead of writing document.query selector container, you can just .style.background color, you can just put it in an element and then use element and so on. That's because the node we have in our code is a reference to the same node that our DOM uses. If that wasn't a reference but a copy like primitive data types behave, our changes would have no effect because the changes would be made to the local copy we have. This behavior is also something to consider when we pass arguments to a function. Let's take the following functions, for example. So we have increase counter object that takes in object counter and object counter.counter plus equals 1, and so this is the object variant and this is the primitive variant. We have a const object with counter of 0 and the primitive. If we increase counter of object, what will happen? We'll pass in this and object counter.counter, so it will access the counter and make it plus equal 1, so counter will be 1, and increase counter primitive will take in this and plus equals 1, it will also be equal to 1. Take a moment and guess what will happen to object and what will happen to primitive after we make the function calls. Alright. If you answered that the object counter will increase by 1 and the primitive counter wouldn't change, you're correct. Remember that the parameter object counter contains a reference to the same object as the object variable we gave it, while primitive counter contains only a copy of the primitive value. Alright, so if we say console log this, it will equal 1, but then after that if we console log primitive, it will still equal 0. Reassigning object data type variables. While mutating the object, we have a reference. Let me just drink some water because my throat is going numb. That's what she said. While mutating the object, we have a reference to the object. While mutating the object, we have a reference. While mutating the object, we have a reference to will affect I understood. So while mutating the object, we have a reference to affect our other variables that reference it. Reassigning a variable won't affect what the other variables refer to. So for example, we have an object animal with species dog, and we have a variable dog that is equal to the object animal. So reassigning animal variable with a completely new object, and the one right here will have a copy of this, and the object is dynamic, so it will change to cat while this variable will stay as dog. It will save like a snapshot of it, and after that we can change the object. It will dynamically change, but here we store like a snapshot of it. Intermediate, advanced array magic. Let me just see how much we have left. Alright, this is quite long, so before I go on to that, I'll have a quick break of 5 minutes, and I'll be right back because my throat hurts from speaking. I'll do a 5-minute timer. Alright, starting timer for 5 minutes, and I'll be right back, guys. Thank you so much. Alright. I'm back, boys. Thank you for sticking with me. We've got a bit more left on objects. Thank you for everyone that subscribed. I can see again my fucking subscriber goal is not working properly on the stream alerts. Yesterday they were working, today they're not working again. I don't know what's happening, but anyways, thank you so much for everyone that subscribes. I really appreciate it. Thank you everyone for tuning in and liking the stream. I am flattened by you guys. Thank you so much. Flattered. How do you say it in English? I'm not sure. Anyways, intermediate advanced array magic. So besides being a quick and handy way to store data, arrays also have a set of functions for manipulating that data in very powerful ways. Once you begin to master these functions, you start to see ways to use them all over the place. There are really only a handful of these functions, but as you soon see, the possibilities of what you can do with them are near endless. As an example of what we mean, let's consider a sum of triple evens function. It will take an array for every even number, it will triple it, and then it will sum all of those even numbers. You can try thinking of how you could implement a function like that using pseudocode. So we need to perform an operation only on the even numbers. We need to transform those numbers by manipulating them by 3. Finally, we need to add the result up from the previous transformation. So using that logic, you may end up implementing something like this, and we have a function that takes in an array, initialize sum of 0, and starts a for loop until the it traverses the array. So until it traverses the array, if array.I divided by 2 doesn't leave a reminder, you triple that number and const triple number, so you put it in a constant variable, triple it, and then some adding the tripled even number, and you return the sum. So in the above code there are 3 important snippets to consider. This one checks if the number is even, multiply the number by 3, add that number to the total. Every single piece solves a crucial problem in our code, but is it possible to make the function more concise and readable by using some built-in array methods? These methods are slightly more complicated than you've been used to. Let's take a moment to understand how to use them. The map method. Alright, I know this is very important, so let's focus here. Map is one such function. It expects a callback as an argument, which is a fancy way of saying I want you to pass another function as an argument to my function. Let's say we had a function add1, which takes in num as argument and outputs num increased by 1. And let's say we had an array of numbers, so 1, 2, 3, 4, 5, so on. And we'd like to increment all of these numbers by 1 using add1 function. Instead of making a for loop and iterating over the above array, we could use our map array method instead, which automatically iterates an array for us. Okay, we don't need to do any extra work aside from simply passing the function we want to use in. So we have a function add1 which takes in number and returns num plus 1. We have an array and we have a mapped array which with the array map, and we can pass a function to it, so it will traverse the array and execute the function on each one of the array items, which is very cool and powerful, as I can see. Map returns a new array and does not change the original array. Okay, so you store it in a new variable. This is a much more elegant approach. What do you think? For simplicity, we could also define an inline function right aside of map, like so. So yeah, what they're doing is they have an array of 1, 2, 3, 4, 5, and they set a constant of map array, and then they use array.map, and inside of the brackets they make an arrow function that takes in num and returns num plus 1. Cool. The filter method. Filter is somewhat similar to map. It still iterates through the array and applies the callback function on every item. However, instead of transforming the values in the array, it returns the original values of the array. Instead of transforming the values in the array, it returns the original values of the array, but only if the callback function returns true. Let's say, alright, so this is a way to filter stuff. I understand. Let's say if we had a function isOdd that returns either true if a number is odd or false if it isn't. The filter method expects the callback to return either true or false. If it returns true, the value is included in the output, otherwise it isn't. Consider the array from our previous example, 1, 2, 3, 4, 5. If we wanted to remove all even numbers from this array, we could use .filter like this, and they basically define a new function isOdd that takes in a number, and if the number divided by 2 has a remainder, basically it's an odd number, so it will return true. We set the constant array, and we do const odd numbers, which is array.filter isOdd, so on each. It will iterate through the array, it will traverse it, and on every single item it will call the isOdd function, and whenever isOdd returns true, it will take that item as an output, and the other ones it will skip it. So console log odd numbers, it will return 135, and if we console log the array, it will return the whole array. Alright, that makes sense, pretty cool. Basically, the difference between them is that the map will execute a function on each item and it will return it, and filter will do the same, but it will return it only if this function returns true. Okay, so filter will iterate through the array and pass every value into the isOdd callback function at a time. isOdd will return true when the value is odd, which means this value is included in the output. If it's an even number, isOdd will return false and not included in the final output. The reduce method. Finally, let's say we wanted to multiply all alpha. Let's say we want to multiply all of the numbers in our array together like this: 1 times 2 times 3 times 4 times 5. First we have to declare a variable total and initialize it to 1. Then we iterate through the array with a for loop, and multiply the total by the current number, but we don't actually need to do all of this. We have our reduce method that will do the job for us. Just like map and filter, it expects a callback function. However, there are two key differences with this array method. The callback function takes two arguments instead of one with the reduce. The first argument is accumulator, which is the current value of the result at that point in the loop, with accumulator, which is the current value of the result at that point in the loop. The first time though, this value will either be set to the initial value described in the next bullet point, or the first element in the array if no initial value is provided. The second value, the second argument for the callback is the current value, which is the item currently being iterated on. It also takes an initial value as a second argument after the callback, which helps when we don't want our initial value to be the first element in the array. For instance, if we wanted to sum all the numbers in the array, we could call reduce without an initial value, but if we wanted to sum all numbers in an array and add 10, we could use 10 as our initial value. So I didn't quite understand that fully. Let's see how it works. We have again a constant R, an array of numbers of 1 through 5, and we then have a new constant product of all nums, which uses r.reduce. So the total is the accumulator, and the current item is the one that we iterate on. And we also have an initial value of 1. And we return total times current number. So the total is like we'll start iterating through it. If we have an initial value of 1, it will be 1 times 1 equals 1, then 1 times 2, it will equal 3, so the total will be 3, and then we take that total and we're on the third item, so we'll do total 3 by 3, which is 9, and then we'll go on, and the output will be 120. So I kind of understand it. In the above function, we pass in a callback function that is total current item, and it will return total times current item. Initialize total to 1 in the second argument. So what reduce will do is it will once again go through every element in the array and apply the callback function to it. Then it changes total without actually changing the array itself. After it's done, it returns total. Alright, so I kind of understand that. If I understood this like 9 out of 10 and the other 9 out of 10, I understand this like 7 out of 10. Alright, so summary: you've learned about 3 powerful array methods, which are map, filter and reduce. They allow us to write shorter code that is more readable and less prone to bugs, because less code is less chance to have a bug. For a quick recap of these array methods, consider this picture which should visually explain them in terms of sandwiches. Alright. we have filter, which will only take in some items, will only return some items. We have map that will execute a function. On those items. So in the first step, I don't know if you went to a kebab shop or döner, where they ask you which one of the ingredients you want, and you filter out which ingredients you want. Then the guy will do a map. So basically he will cut the bread, he will cut the, is this pepper, I'm not sure, tomato and lettuce. He'll cut them up and then he'll use reduce to put it all together and update the total. Alright, let's do some quick practice before your assignment. Rewrite the sum of tripled evens array function using these three methods. Once you're finished and you've tested that your function works correctly, check out the solution below. So I'll quickly copy it and let me open up. Do I have VS Code open? Yes, I have it, but I don't want to work here. CD. I'll just do touch example.js. I also have to make an index of cd into repos, make dir Odin x cd into Odin okay, and code dot I'll make a new file, index.html, add in the boilerplate script tag, not like this, script src script.js, make script.js, add in that, and I'll quickly start the live server, put it on the right, okay, and just so we can see it, we'll console log this sum, not return it, console.log sum, and we also need the array, so const r close 5, and we also need to call the function sum of tripled evens. I need to take the r, it's not defined, yeah, not sum but sum, it's 18. Alright, so the evens is 1 times 3 is 3, 9, 5 times 3 is evens, not odds. Okay, so 2 times 3 is 6 and 4 times 3 is 12, so 18. Okay, so we have to rewrite this using the map filter and reduce filter and alright, reduce. So what we can do is first we can filter the array using the filter. So we can make a new function is odd function is odd. We actually want even, although it doesn't matter. And it will return true if we actually have to pass in a number, so num. If num divided by 2 doesn't leave a reminder, return true. I believe we can also just do like that and it will return true, but I'm not sure. Otherwise return false. I actually don't think we even need the false, because filter will only give us the numbers that we return true on, and if we don't return false, it doesn't matter. So as of right now, we can make a const sum, which will initialize as 0, and we can make r dot filter and is even, that will take let me console log this. Num is not defined. Okay, so do we have to put in the whole array? No. So how did you do that? Is even? No. JS filter. Filter word. Do we have to first define like num and then my thing is how did you not make it an arrow function? Because I can make it an arrow function now, but I don't want that. I want to see first just a sec, not here, but is sort r dot filter is sort. But here it says it takes in a number and we don't put in a number here. Alright, let me do it. Console log r.filter is even without putting anything in it. So it will give me 2 and 4. Perfect. Okay, so let's try now to make this into an arrow function. R filter, so for num We do an arrow function is even. And can't we actually return times 2 equals 0? Missing. So yeah, this works now. Was this the way to write it? Forward.length. Yeah, so it will return all the numbers that return true to this statement. Alright. And then after that, what we want to do is do a map with the numbers we get. So after this array, we can use .map, and then we want to return basically every number times 2. Maybe we can do an arrow function again, num, and then return num times 2. So we have 4 and 8. It has to be tripled, so times 3 instead. Alright, and then we have to use a reduce to sum them all up. We can use reduce. Let me toggle overdrop. Reduce, and now it took 2 arguments. I think the first was total or sum, and the second one is the num, and num is not defined. JS reduce. I want to see again how they did it. So you got an array and initial value, you got the sum, alright, so let's say this will be the sum we do dot reduce accumulator current value, and then after that we do sum plus num. Oops, not like this. No. Alright, can we instead put this in a variable and const to sum equals this, and then can we console.walk to sum, which is, oops, not like this, but to sum dot reduce, and we have accumulator and current value. So the accumulator is the sum and the current value is num. Then have sum plus num. Can we have it like that? 18, right, okay. And so then can we have this instead of writing another function and then console walk to sum? Yes, it still works like that. Alright, kind of understand it. Let's see the solution. So they used they've actually rewritten that. I should have done the same, and they did it cleaner and easier to understand. So function sum of tripod evens takes in array and just returns array.filter num. Basically the same that we did. Alright, that's cool. I'm going to minimize this for now. We're up to the assignments, so I'll just quickly check what assignments we need to complete. Let me just stop the live server for now, we don't need it. Okay, array method guide. Okay, this is another thing to read through, but I think I'll do it off stream because it's quite boring to read this whole thing on stream. Read through the array method guide for a comprehensive overview of array methods in JavaScript. Complete the exercise at the end, except for create an extendable calculator, as it involves more advanced concept that we have not covered yet. Follow up by watching. We have a video to watch. Cool. Let's see how long it is. Video by Westboss, perfect. I kind of like how this looks. JavaScript array mastery. Maybe I'll watch through this as well. It looks interesting. Follow along fork and clone this repository. Array cardio day 2. So watch 2 videos. At this point you just need a little more practice. Go back to the JavaScript exercise repository that introduced arrays and loops and so on. Alright, perfect. So I'll probably take a quick break now and look through these, and hopefully tomorrow early in the morning I'll be done with them and we can start with those exercises. And after that is just this page that's a quick read, and we can start with the calculator. Perfect. So I'll read a bit more of stream, watch through these videos because they seem interesting, and I think tomorrow in the morning we'll be able to start with these exercises, finish them up, and then after that we'll start with the last project from the fundamentals, that is the calculator project. I want to quickly thank you all that tuned in today or that watched the recording on YouTube. I truly appreciate you guys. I will not stop making those videos and we'll succeed together. So that was it from me for today, and we'll see each other tomorrow early in the morning. Alright, peace out, bye bye.